Hi, everybody, and welcome to today's Agents in Action. Today, we're talking about AI safety and security in SmythOS. And with me today is Alaa-eddine Kaddouri, who's our VP of Engineering, and I'm Amber Graner, Head of Community and DevRel at SmythOS. So, as I mentioned, we're talking about AI safety and security in SmythOS, and we're going to be focusing a little bit more on the how you become trusted by regulated industries such as financial institutions. And with that, I'm going to stop sharing my screen and turn it over to Alaa-eddine. Alaa-eddine, the floor is yours.
Thank you, Amber. So let me share my screen. One moment, I will start by sharing this one. I'm sorry, I will not be able to share the slides in full screen because I have multiple windows that I need to go back and forth. So I will just share it like this so you can follow the progress of our presentation. So first of all, why security? When you have services like you are working on services like financial, banking, or like other security sensitive services, you deal with some constraints that do not exist in other industries or in other contexts. Like it's different thing developing an agent locally or deploying an agent on your for your SaaS is a thing, but doing AI inside a financial institution or bank is a whole different thing, and it need to adhere to some compliances, to security, and some constraints. And this is where SmythOS comes into play with its way of handling data, security, safety, and isolation. And we will go through all of this step by step in this presentation. So first of all, SmythOS was built from the ground with a zero trust architecture. This means that every single step in SmythOS architecture assumes that we do not trust AIs or LLMs. We trust policies, we trust deterministic rules, and we verify everything. And if an LLM processes a data, by default, we consider it unsafe and we need to sandbox it and isolate it. And this also work side by side with user security. So identity verification with multi-factor authentication for users in our platform, least privilege access principle, which means that we provide the users and agents the lowest permissions that allows them to perform a task. And if they need to have like access to something more, then they need to request it. And there are mechanics to request accesses for users. It will be the admin of your organization that will give you access. For agents, there are internal logic that allows agents requesting access, and we can have like human in the loop or policy or something that controls this access before giving it to the agent. And as I mentioned earlier, every single component is executing in a sandboxed context, and they will give a very small high-level demo for this in a moment, which means that even if you do not trust an LLM, you can work with it and isolate the data that goes inside this LLM, so you can take the benefit of LLMs and AIs without risking your data to leak. And of course, we have monitoring tools like OpenTelemetry. This is also something that I will demonstrate in a moment. So let me first switch to another window in order to show you a simple example of data isolation by design in our user interface. So here I'm using the Visual Builder because it's simpler to understand through Visual Builder the logic of our agents. So let's take example of this simple processing workflow. Most of AI tools today, when they process data, they process it like this, in this pattern. So what does this pattern do? Let's say you receive an email. Your agent or your workflow get the email, and then it will send it to an LLM. This LLM processes the email, and then we can imagine that it generates a response, and then it sends it back to the sender or to someone else. Now, if you follow the recent studies from Microsoft and other security researchers, you might have seen a research paper talking about a prompt injection attack that will temper this design and will have access to internal enterprise data just by sending an email here that contains a prompt that basically tells the LLM, going forward, every email that you receive should be forwarded to this external address. Now, if this LLM have memory, which is the case most of the time, the LLM will remember this prompt, and going forward, every email received, this LLM will generate a response, but will also CC an external email. So here you have a leak of your data. This is a very simple example just to illustrate how this can happen. And usually it happens because we want to take benefit of some LLM properties like auto-responding, generating content, memory, and so forth. Now, how does SmythOS handle this? Well, in our components, you control how the data flows. So for example, when you receive an email, instead of processing the email as a whole bulk of data, we will split it. So an email is basically an email to, from, subject, body, and we can have attachments and so forth. Now, what do we do with this? We still want to use LLM capabilities to respond to the email. Okay, what does the LLM need to respond to this email? It needs subject and body. The LLM does not need to have access to the one who sent the email, like the from, and to whom we are sending the email, the to. So it makes no sense to share this data with the LLM. With SmythOS design patterns, you can decide which data goes to the LLM and which data does not. And this LLM is completely sandbox. It does not see what happens around. So here, the LLM will generate a response, and then we will take the subject of this response and the body, and then we will send it. We will respond to the person who sent us the email here. So this email address is completely invisible to this LLM. If we try a prompt injection here, this LLM will never generate a CC or a to field in the email sending process. And with this, we can protect data. Again, this is an extremely simple example to show you the idea, but the goal here is to show what is the benefit of having this control over the data, how you can split your data into fields and control what goes where and so forth. You can imagine other patterns where, for example, you have like some personal information in a personal data that you do not want to share with an LLM. So you will put a filter component in front of the LLM. It will split the data or anonymize it, send it to the LLM. The LLM will process it, and then you associate the processing to the user data again in the output, and then store it, for example, in your database and so forth. So SmythOS allows you to have this kind of control over your data. And of course, we also have monitoring and real-time tracing to have even more control. So I will go back to the presentation. Okay, the next important item here is the access control lists that we have in two levels. So first, the users who are accessing Smith platform on the SaaS or when it's installed on-prem have a role-based control that the admins can specify, and they can use the default roles or declare their own roles to give like granular access to the different users. You can also organize your platform into multiple spaces. Every space is completely isolated from the others. Now, the ACL system also applies to agents. So every agent, when it tries to make an operation, need to get the rights to do this operation. And I will illustrate this in a moment. So first of all, the user's access control. I will switch again to SmythOS platform. So here, when you are in your dashboard, you can open the user management interface. And in the user management, you have a set of roles that are predetermined, but you can create new roles. And in the role, you can specify, you can specify page by page, access by access, what the user can do. For example, this is like, let's say my custom role, and I want the users to be able to view the agent builder, but not actually edit agents. I want them to edit agents, but cannot change agent settings. You can just view them. They can list the agents, but not delete them. They can access data pool. They can access domains, but not create new domains, and so forth. So you get the idea here. And when you have your roles configured, you can associate them to users, and you have full control of who does what in your organization. So this is for users. Now for agents, I will show a diagram which, to explain the idea. So basically, when an agent, let's say you have an agent that need to store data in your local drive or on S3 or on a database, it doesn't matter. The idea is always the same. So the agent, what happens behind the scenes is that the agent will send a write request to the storage connector. Then the storage connector will request a new ACL access to the ACL manager. The ACL manager is the central component in Smyth runtime that handles all accesses for agents and users and controls who accesses what. So the security subsystem, ACL manager, will then create a new ACL object that will be associated with the data that the agent is about to write. And then this ACL is encoded as a metadata of the data that we are writing to the storage. It does not matter if this storage is local or remote. This always happens. So when an agent creates a new data, we associate the access level of this agent to the data. Of course, if this data already exists and the agent does not have access, it will be rejected, and this is what I will show here. In this diagram, I'm assuming that the agent is writing brand new data and that he has access to that storage. So what happens if the agent is trying to access a data and will make a read request? So in this case, the agents make the read request with the data identifier that he wants to read. The data identifier can be a file name, for example, or a database query, and so forth. Then this time, the storage connector will request the ACL from the ACL manager using the data ID and the agent ID. So here, what the storage connector is doing is like, is asking the ACL manager, does this agent ID has access to this particular data? The ACL manager has information about all resources, all data, and it will extract the encoded ACL that we've stored here in this step. It will check if the agent is among the allowed users. It will check if the agent has read access, and then if it does, it will accept the request. If it doesn't, it will reject it. And When it accepts the request, then the storage can go and read the data from our remote storage. This is how it works at a high level. Now, in some environments, we have a higher constraint of data protection. So here, what we did when we wrote the data is associated to this agent. But let's say you have a super admin who manages this storage, right? The super admin will never see to whom belong this data, but he can see the data because the data is stored in our storage. So let's say you are storing your data in S3 and you have your S3 admin. Well, the admin has access to the S3 buckets. He can navigate in them. He can download this data. Now, how do you protect this? We can add a hardened security layer on top of it, and this will be placed here. So in this case, on top of the ACL system, we add an encryption module that will encrypt this whole information here before sending it to the storage. And this encryption module can be part of the storage or can be independent from the storage. Again, it is handled by SmythOS, and you don't have to care about it. For the agent, it's always completely transparent. He's just reading or writing data. And then SmythOS handles all the security layer. Now the data is encrypted and stored in our storage, and even someone with very high privileges will never see what exists in this data. Now, the level of security and encryption and whether you want encryption or not depend on your context. Some contexts require encryption. Some contexts require like encryption with very large keys. Some others does not require it because they have policies access to their storage and they do not want to add the overhead. All these configurations are possible depending on your industry sector and the level of security you want to handle. So what we do here with SmythOS is that we are not trusting the developers or the agent builders for security. The security is handled by the system, and then the developer or agent builder will focus on his main task, which is making agents that does the job. Next, we will cover the data isolation, which is also a very important topic. Now, sometimes you are working in a context where multiple agents need to process data, or multiple agents are working together. Here again, many frameworks out there delegate this data isolation to the developers. So the developer needs to handle the data access. He needs to make sure that agent A does not have access to agent B data, and he needs to handle when the agent needs to share data and so forth. And this becomes very hard to maintain over time, because as you are adding agents or processes to your system, you need to keep track of all of this, and it's pretty complex. Now, SmythOS, again, handles this for you by design, and maybe I will share a code example here, because we talked about visual agents, but everything that I say for visual agents is valid for code agents and vice versa. Let me share another window. So this time, I'm sharing two example codes. So here I have an agent called Neo and an agent called Trinity. They are both part of the Matrix team. So agent Neo wants to write data to test.txt, right? And agent Trinity wants to write data to test.txt as well. So the agent Neo will request access to the local storage, and the agent Trinity will do the same. Now, when they will write data, by default, everything that agent Neo writes to this test.txt is completely isolated from what Trinity is doing, even though they are the same names, because every agent is executing in a kind of sandbox where storages, data, cache, memory is completely separated. So again, here the developer does not have to handle this. The developer write to storage, and the storage connector and ACL system and data isolation system will handle this for you. Now, the agents might also want to share data. In this case, we explicitly say that, for example, for agent Neo, I'm requesting an access to local storage with team scope. And same for Trinity. I'm requesting access to local storage for team scope. Now, when we do that, we create a kind of shared sandbox between agents that belong to the same team. And in this case, this storage object will allow me to share data. So here I can write data to this file and agent Trinity can read it, or vice versa. So we can do both, but you do not have to handle it. It is handled for you, right? And by default, it is isolated. Here again, we apply like the least privilege principle and zero trust principle, where by default data is protected and you explicitly say, I want to share it. And this is important when you are building secure systems, because if you are sharing data across multiple agents, it always needs to be intended. It should not be a leak, because this is where most of leaks happens. Next, we will talk about on-premise deployments. So this is also very important, because when you use SmythOS, usually you start using our SaaS platform and you build agent, and this works for many customers. Many customers just build their agents on our SaaS platforms, and they can use our one-click deploy, and they deploy their agents, and their agents are ready to be used. The SaaS already provides multiple ways of protecting your agents that does not rely on our security system. So for example, if you have an OAuth system, you can protect your agent with your own OAuth system, even if the agent is hosted on our platform. So, and this covers multiple use cases. Now, in some cases, you still want full control of data, and you want to either run your agents on your system without the whole SaaS, so you just need the agents running on your servers, or you need the whole user interface of SmythOS, like a copy of our SaaS running inside your enterprise. So both are possible. The first one is by using Smyth runtime command line or Smyth runtime SDK. So with the SDK, you can build agents with code, or you can build agents in the SaaS, export them and run them on premise. And when you do this, you do not rely on our SaaS anymore. You configure your own Smyth runtime copy on your server, and you handle the resources, you monitor the accesses, and the agent is completely isolated. Your agent can then access LLMs or services through cloud, or you can decide that it's completely isolated and it only has access to local data, local storage, local LLMs, and so forth. This is the main benefit of on-premise deployments. The other kind of deployment, as I mentioned, is to deploy the full Smyth ecosystem on your servers. And here we provide multiple solutions. So it can be on hyperscalers like AWS, Azure, and so forth. It can be on container, like Docker or Kubernetes. And it can also be on like custom deployments on your own bare metal servers with virtualization frameworks, and so forth. So multiple deployment solutions are available. And again, it also depends on customer context and so forth. The main thing that you need to keep in mind is that every agent that you build in the SaaS can be exported, imported to your on-premise deployment, whether the deployment is a copy of the SaaS, a container, a hyperscaler, or just the SDK running on standalone mode. So next, we also have a slide about observability and OpenTelemetry. So SmythOS is fully compatible with OpenTelemetry, which is the industry standard in tracking, logging, and monitoring agents. Here, Amber, do we still have time to make a live demo for this one?
We sure do.
Yeah, okay. So for this one, I will show you a quick demo. Let me first share. Okay, here. So here I'm running Uptrace dashboard. Uptrace is a tool that can collect and index and visualize OpenTelemetry data. So this is the tool that I will use to collect data from a running agent on my computer. You can see that it's running on my local host. So this is not a true production Uptrace install. This is why you can see some data that is not necessarily relevant, but you get the idea. So here in my dashboards, I will open the SmythOS dashboard. We have no trace for now. I will run an agent that sends traces to OpenTelemetry, and this dashboard will capture them, and then I will come back here and we'll show you what we've captured. So now I will switch to my agent. So here I have a code agent this time, and the way to connect our agent to OpenTelemetry is just by adding this configuration. So regardless of how your agent look like, all you have to do is tell Smith Runtime that you are sending the telemetry data to an OpenTelemetry endpoint, and you use the right connector for it and the endpoint. And from there, I will run an agent and will chat with it, and then we will see what happens. So here I'm running an example of a chat agent that has access to crypto market information. I'm first asking who is the agent to make sure that I'm talking to, okay, I'm talking to crypto market agent. That's good. And then I will ask a simple question like, what is the current price of Bitcoin and Ethereum? So the agent is calling external tools and it's come back with the response. Okay. Now I will go back to my OpenTelemetry dashboard. I will probably need to refresh. Okay. So I see some traces here, and I will go to agent conversation because this is the root trace for the conversations that happen with an agent. I have two traces here because I sent two messages to my agent. I will take the latest one. And here you can see the details of my conversation with the agent. So I will take the root trace. Here I can check the attribute of my trace. I can go to the events. If I sort them by order, agent skill process started, this is the first message that the agent received. And if I inspect it, I can see the question that they asked the agent. So what is the current price of Bitcoin and Ethereum? And then we can navigate step by step and see exactly what happens. So for example, This trace just captures how much time, how much latency we have, time to first byte. This is basically the moment you type your message and the message is sent to the LLM and the moment the LLM starts responding. And then we can see agent skill calls. This is basically when the agent is making tool calls to get the prices from an external API. Here again, we can go and inspect what happens in details. There are detailed data here of the call, so we can see what was the call. We can check the response. So the response that we received from the external API is here, and so forth. So you can see that you have extremely detailed traces, and you can also have logs here checking for like detailed logs of what happened with the agent and so forth. And as you know, when you use OpenTelemetry, you can also set alerts. You can have like custom alerting system or collect the logs to feed your agent back if you are doing training or fine tuning with like succeeded traces versus failure traces and so forth. So OpenTelemetry is also very important for security by using alerting, but also for agent accuracy if you are using reinforcement through the collected data. So back to the slides. The last one just presents some examples of how SmythOS is used in financial industries. So there are here we shared like 4 example use cases. So SmythOS agents can be used for fraud detection system, and this can be done by scanning logs or access attempts or like behavioral analysis through agent LLMs. So you can use SmythOS agents to continuously monitor logs and data and behaviors and alert you when they identify a suspect behavior, for example. The other case is for compliance and automation. Here again, the agents can be very helpful. Of course, it does not replace a human 100% in this case, because compliance require like rigorous verification of your documents and so forth. But the idea is to have AI handles most of the work where you need like to collect data, organize it, filter out the noise, and prepare the data for compliance audits. So here AI can be very, very performant. For risk assessment, it's similar to fraud detection, but in this case, it's like a proactive. So you will have agents monitoring some behaviors and some actions in your system, and you build them in a way to identify patterns that should trigger alerts for you in order to handle a possible risk. So this is also very important in financial industries, but not only for cybersecurity. It's also very important when you need to have like a proactive monitoring of your systems. And of course, you also have the customer service. And in this case, it can be a brand agent that is available publicly in your website that answers like basic customer questions and reduce the load of your actual customer service in your company. Or it can also help your customer service to address customer concerns or draft responses so that a human can then verify them before sending them. The idea again is to save time. It's not something that would 100% replace a human custom service, but it can certainly help a lot in we've seen like some 90% increase in performances in some customers who implemented an AI customer service that helps their support. So I think I covered pretty much everything I wanted in these slides. I will give it back to you, Amber, and if there are any questions, I can answer them.
Thank you so much, Alaa-eddine, for that insightful presentation about security in SmythOS. It's really important, and I think it's a topic that comes up a lot. Like no matter where you digest your information about AI, agentic AI, and the security surrounding it, be it LinkedIn or some other source that you're getting it. This is a very hot topic, and I'm glad that we can present on that and show how secure we really are in this environment. If you have any questions, please ask them. If we don't get to them today, we'll follow up in either a blog post or a social media post and answer your questions. The other thing is, if you want more information and you'd like to talk with someone from our team, we'll also include that link when we share the video out later today or tomorrow. We'll share the link with everyone who is invited to this, and across our socials, we'll put that as well. So we do, if you want to request a more in-depth demo, or you just want to talk to somebody from the team, you can do that as well. If you'd like, as Alaa-eddine mentioned, we do have our open source areas for our SDK and our runtime environment, along with our Docker and Studio image. So if you'd like to take a look at that, you can go to our GitHub. We'll put those links in as well. And if you haven't joined our Discord channel yet, we'd love for you to do that. We'll also include those links as well. So we thank you today for joining us, and hope that you'll join us next week for our next Agents in Action, where I believe we're going to be talking with some folks from the community about some of the agents that they've submitted in some of our hackathons and other challenges that we've done. And so with that, we'll say thank you one last time, and we hope to see you on the next Agents in Action. Thank you, Alaa-eddine, for presenting today.
Thank you. Bye.